Okay, so first off, let me just say, why do we bother making you do math history? That's often a question. And what is math history? Though people will ask me that too. So I usually say, well, it's math and it's history. It's a combination of the two. You have to do both. What that means for us is that you'll be doing some of the math, like we'll be multiplying the way that Egyptians multiplied and stuff like that. So you'll learn some of the old techniques and why that's helpful for us today. And then the history part is looking and seeing who developed what. So for instance, we often have this notation dx dt, or I'm sorry, dy dx, that's what I'm after. So that notation for taking a derivative. And the question is, who came up with that? Why do we use it? What does it mean? So all of these things in our background come up, and we say, okay, why are we doing that? And that's what the math history is going to help us know, and hopefully help us not make some of the same goofy mistakes that they made back then, and we'll learn from them. So what is math? That's my current question. What is math? Nobody knows? What does involve? I'm just going to put you on the spot for a moment, and then if you don't have it, we're going to try to help you. Numbers, absolutely. Study of numbers, quantities, spaces, like in geometry, we study space, right? Different sizes, different orders of things. What is math? Oh my gosh, there's so much. But the one thing that people often normally say is exactly what I heard here, numbers. It's the study of numbers. So that's what we're looking at. It's the study of all these things. Okay, absolutely it is. So, what are numbers? And why do we have them? How do you think they were developed? Oh my goodness, so many esoteric questions, right? So we know for those of us who are using like Romance languages normally, 1, 2, 3, those are our numbers, right? By the way, those are, anybody, bonus brownie points. What kind of, They're Arabic, yeah, they're Hindu Arabic numbers, right? Which means that basically we stole them, right? We appropriated them, we used them, borrowed them. You need a pen?
All black.
Okay. They're all black, oh no. So we borrowed them from the Hindu Arabic people, right? The Arabs in particular is where they came from. So these are our numbers, but those are just a symbol, right? They represent stuff. So what are numbers at their core, and why? Why do we have them? What's the purpose? I know, so much on the spot, right? So there's a lot of theories out there. So in the background, what we see is almost every culture ever recorded has some form of number. Some form of numbers, okay? So they have something to indicate that they were keeping track of stuff, okay? That's what we use numbers for, right? So if I, for instance, let's go back to the very first civilizations that we know of. What if I'm nomadic, okay? A nomad, I'm chasing, I don't know, herds of deer or antelope or whatever I'm chasing. bison, whatever whatever it is you're hunting to keep your family alive. And we're hunting, and why would I need to count something? Keep track of stuff. Maybe I need to know how many people are in my family, because I need to feed 4 kids and a wife, and so maybe I need to use that information to figure out, okay, there's 6 of us total, and I need to shoot, I don't know, a deer a week or something like that so that we can stay alive. Maybe if we're nomadic, then we have to pick up our huts or whatever we're traveling with, whatever we use for shelter, and carry everything with us every so often. So maybe we need to know, oh, there's 6 bowls and there's 6 furs and there's 6 whatever, so that we know we've got everything and we've got it all packed up and we can go. Those kinds of things. So if I'm nomadic, then maybe those are the kinds of things I'm after. A little later, we start seeing civilizations that have settled. So usually those end up being around riverbeds. And that's interesting. So there are 2 major areas that we know people settled really early. One is around the Nile River. Brownie points, what's that civilization around the Nile? Egyptians. Those are the Egyptians, right? Okay, so that's one area. And then there's another area around the Tigris, Euphrates rivers. And these are more in the Middle Eastern area. There are 2 rivers that kind of do this, and they come together-ish, and there are civilizations in between them. Anybody know which civilization? The Babylonians settled around the Tigris, Euphrates. Yeah. So those are the 2 very, very early civilizations that we know of by name. And they're both settled around riverbeds. And both of those actually range from about 3000 BC to about 5000 BC. So they're really ancient. And we're going to talk about them more this week and get some stuff going about them. But for right now, we'll just say, okay, these civilizations, they settled around the riverbeds, and I can have my own herd of sheep that I take care of, and pasture land and stuff like that. So as we settle, it's actually interesting because now I'm able to spread out more, and now I'm able to have more possessions, and now I have more stuff to keep track of, more stuff to count. So there are theories. So I'm going to give you some theories for why did we develop numbers, what happened. One of the theories, and this is the number 1 theory, that like if you look in math history textbooks and you find stuff out, one of the main theories that's out there is that when people started settling around riverbeds, that they needed to keep track of harvesting. Okay, so I need to plant my crop at a certain time. I need to harvest my crops at a certain time. We know for a fact that the Nile River in particular flooded a lot. And so if I've planted crops and it's near the Nile River, I want to get my crops out before the floods happen, right? So I need to keep track of that. And the way that we normally keep track of those things whenever we don't have modern inventions like TV and radio and loveliness like that is that we will keep track of lunar cycles. Okay, that's a very common way for early civilizations to do things. So it's the lunar cycles. That's the most commonly believed theory for the first time that man really started keeping track of numbers and stuff like that. So if you look in a lot of historical pictures, there will be bones or tree limbs or knotted beads or knotted ropes or ropes with beads on them and things like that. And all of these things keep track of number. So in particular, you'll see groups of 30 in there, which is really close to what a lunar cycle is. So from new moon to new moon or from full moon to full moon, to see how long does it take before that happens. And maybe my plants grow for 2 months, so I need to in 60 days, I need to take those plants out before the river floods, those kinds of things. So that's the most commonly believed theory for why we keep up with stuff. And interestingly enough, so the two early civilizations we mentioned were the Egyptians, where we know there was a lot of flooding, and the Babylonians, and we'll talk more about them on Wednesday. But the Babylonians, they're an interesting group because they used 60 for their number system, which is 2 groups of 30, as we all know. And so it's really commonly believed that the reason why the Babylonians used base 60 is that it was based on a 2-month lunar cycle where they could harvest things and plant things. And, oh, you're going to have flooding for this long, it's going to be about 60 days, or you're going to have bad winters for this long, those kinds of things. So that the cycles, the seasons and things like that, they were counting in 2-month periods, basically. On the other side of the world, and we're not going to get too much into them, but on in the new world, we've also got over here Mayans, the ancient Mayan civilization, which interestingly enough, they had we actually know about them. The Mayans had a really accurate calendar, right? Like it just ran out not long ago. I don't remember when. And people thought the world was going to end because the calendar ended, right? Do y'all remember that? So their calendar was actually, and I don't want to lie to you, I think it was 360 days. Nope, 365 days. So really accurate. And the way they got that was they had a year of 18 months of 20 days each. Okay. So it doesn't quite line up with a lunar cycle, but interestingly enough, what they had, 18 months, 20 days each, their 20 days each, they had a base 20 system. So the Babylonians had a base 60 system because they were working on a 2-month cycle, and these used a 20-day month, and they had a base 20 system. So interesting. When I teach a math education class, a lot of times I'll say, these are your God-given manipulative. You have 10 of them, right? And our base is what? Base 10, right? So there's a lot of stuff out there that lets us know that's probably where some of these things came from. So for us, it's base 10. For the Mayans, it's base 20. For the Babylonians, base 60. Okay, another theory. So the main one you're going to see popping up in your readings and stuff is all about the lunar cycles. But another theory is, okay, say I have sheep or goats or whatever I'm keeping up with, and I've settled, I have my pasture land, and say that I want to let them out into the pasture for the day. I have them in a little paddock area. So what I would have is a pile of rocks. I know, lovely picture here, right? I have a pile of rocks, and as the sheep go out, I move a rock and I put it in a pile over here. So 1 sheep, 2 sheep, yada, yada, yada. And I make a pile of rocks over here. And the idea being that I have 1 rock per sheep. Okay. I don't necessarily need that symbol, the symbol 1, 2, blah, blah, blah. I just have a rock that represents that sheep. And so I put it into the pile, 1, 2, 3, however many. When they're all out for the day, my pile of rocks is over there. When they come back for the day, I move a rock for each sheep back into the other pile, right? So at the end of the day, they come back over. Okay. Now, this is useful to me because if I still have piles left over here, like if I still have 3 rocks sitting over there, then I know that, okay, I still have 3 sheep out there somewhere. Either coyotes got them, wolves, whatever. Maybe I need to go looking for them. Maybe they're lost. I don't know. But I know I'm missing some of my livestock. Okay. So an idea for that, the way that we keep track of things, the reason why we keep track of things, could be livestock. It could be crops to make sure. Later, once we've developed a little more in our civilization, I'm probably going to end up wanting to barter stuff, right? So if I look at that and I say, hey, I have 3 sheep and you have 2 cows, can we make a deal? Okay, is that worth it? So we both have to decide that's a good deal, and the way we do that is to put a value for that 1 sheep, right? Whatever it is. Nowadays we'd say, oh, $300 for the goat or whatever, But they didn't have that early. So, okay, 3 sheep is worth 2 cows, maybe. I don't know. So bartering, and then a little bit later, and we'll see this as we come up, in the Roman times and stuff like that, we're going to end up keeping track of taxes, right? So then we start having money, and then we start putting values on things, and then we really need a number system where we can write things down to keep track of stuff. But early on, it's probably things more like this. I have a friend who watches Survivor. Ugh, not my thing, but I have a friend who watches Survivor. And do y'all know how they keep track of how many days they're on the island? Anybody watch it? Nobody wants to confess that they watch it. Okay. So, because the idea of Survivor is you don't have any kind of, modern technology or whatever. So they literally take, and it's terrible what they do. They take a knife and they score numbers, tally marks, into trees. Okay, so they have a tree that keeps the tally of how many days they've been on the island. So as they go along, they'll mark it, okay, so that they know this is day 10, this is day 12, whatever we're on. Okay, so poor tree, they're killing the tree, but that's what they do. So, but that's very primitive, right? That's probably the way certain cultures use things. There are books that have pictures. There's stuff in the Smithsonian Museum where you'll see like a bone from a sheep or a cow or whatever. It'll be like a leg bone that has marks on it, and it'll be similar to this. So the leg will be like this, or the bone will be like that, and it'll have marks. And a lot of times those are like 30 groups of 30. So it's kind of interesting, keeping track of what would happen monthly, whatever it is. That's the idea. That's the theory that's going on behind it. Okay, there's one more theory I want to get out there, and that is about zero. So what do y'all think about zero?
Like one of the greatest things that came to math.
It's a really great process, right? Having a zero. Why is a zero a good thing?
Place value.
Okay, it can hold a place, right? So whenever we get into place values, we can say, hey, if this is the hundreds position and this is the tens and this is the 1, maybe we have 304 items, right? 304, and that lets everybody who's in a base 10 world know there aren't any 10s there, right? 0 groups of 10s, okay? And that's a really great idea. No 10s here. Okay, so we know we have 4 groups of 1, and we know we have 3 groups of 100, but no 10s. So it is a placeholder. Is it a natural thing that I would teach somebody? Like, do we come upon it naturally speaking? Like,
not today.
Not today. What does that mean?
It's just like normal for everybody to like understand how zero works.
Oh yeah, because we're advanced, right? And we know stuff. So today it's okay. But like even with kids, so kids today, you have say a 1-year-old, a 2-year-old, and they're starting to count. How do they start counting? 1, right? Okay, I have 1 piece of candy. I have 2 pieces of candy. I have 1 truck. I have 2 trucks, whatever it is. But they start with 1, right? they don't start with 0. I have 0 trucks, or I have 0 toys, or I have 0 whatever. They start with 1. Okay, and so that's why a lot of times you'll hear people talk about the number systems, and the natural number system starts with 1, 1, 2, 3, 4, or sometimes they call it the counting numbers, right? We call them those. So we start with 1. It's not natural that a kid would just go 0. Okay, but if they had 3 pieces of candy and we took those 3 pieces away, they understand the concept of nothing left, right? Okay, you took my candy, there's nothing there for me. So they get that concept and they understand the lack of something. Something's missing, okay? So that's kind of the idea. So yes, it's a placeholder, but it can be something's missing, something's lacking, that kind of an idea, right, for kids, even today. For our purposes, we know that 0 is actually super powerful, like you said, right? We just almost take it for granted. But for younger generations, back in ancient civilizations, the idea of 0, for some of them, okay, yeah, it makes sense. But some of them were like, no, this 0, what do you mean? Also, we'll see negative numbers are controversial. They'll be controversial. Why negative numbers? I've got a checking account and I overdrafted it by $5, right? It's -5 in the bank. So this is very natural for us nowadays, but there were people who actually really fought with that idea, okay? And the same thing with stuff like irrational numbers. We have those now. And again, they're just kind of normal for us. But square root of 3, what the heck does that mean? How can you develop some number called square root of 3? And actually, this is a big sticking point for the Pythagoreans because, yeah, really it was. People died over this. I'm not even kidding. Because they thought that numbers represented measurements. Okay? So, for instance, if I'm on a triangle and I have sides, then those need to be measurements, okay? Well, if it's a 3, a 4, and a 5, those are good measurements, right? Those are all whole number measurements, and we can measure those. But if I need to measure something that's a square root of 3, let's just square root all of these. Y'all know this is a Pythagorean triple, right? 3, 4, 5. It's a good square root. Good guy. But if I square root all of them, then, okay, square root of 4, we're good because that's a 2. They would have been all right with that. But square root of 3 and square root of 5, how do I measure that? Okay, so you can see where some of these ideas, they're kind of, a bit on the controversial side, a bit of a paradigm shift. I'm going to have to wrap my brain around this in order for it to be okay, is the way those civilizations were working. They were not okay with them early on. So we'll see how some of that stuff developed. So one more little theory, and I'll close on this, I think. Let me check my notes real quickly, make sure I've covered most of what I want to talk about. Sometimes I get distracted. Sorry. Yeah, it's most of what I wanted to talk about. One more little theory, and well, let me back up for just a second. I will say, we are going to cover, I mentioned the Mayans, right? There's a tiny bit of Mayan stuff in the book that you're going to read. There's a tiny bit of stuff about some different civilizations. Honestly, I'm just going to tell you, the Chinese get shorted in this class, okay? I'll mention a little bit here, the Pythagorean theorem, that's Pythagoras, blah, 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 and we'll talk about Pythagoras, but then I'll mention, and the Chinese had it like centuries before Pythagoras, okay? We have now evidence that they had it. They knew it long before whatever we know. The problem is that as you look at the map, and we'll be looking at the map this semester, the Chinese are actually not near us as far as just territorially speaking, right? So when we talk about near Eastern world, that means Europe for us. the Americans, right? For our mathematics that we deal with over here, for the North American population, whatever. So we look at Europe, maybe a little bit of Middle Eastern, but China's way far over there. That's far east. And so they don't get the recognition just because there were boundaries there that kind of separated communications. So one of the things that we're going to focus on here, like we'll start with the Egyptians and Babylonians, but Chinese were there, right? We know that the Mayans were over here in North America developing stuff, but they just don't get some credit. But we'll talk about how some of our history that we look at for European-based history in particular is founded on trading and wars and things like that. Places where this population over here came in contact with this population over here, and whether it was an exchange of knowledge, an exchange of bloodshed, whatever it was, things got traded, and then we brought back stuff. So that's how we managed to steal the Arabic numbers, okay, is because there were the Crusades and back and forth and stuff like that. So we got numbers from them. Appropriate their numbers. Okay, but we got numbers from them. So some of the stuff that we're looking at, for sure, there's no way in a 16-week course I can cover every bit of math history, right? We're not even, honestly, we'll get to like about the 1700s, and that's as far as we can get. So, we run out of time. Okay, but there's going to be stuff in there that I'll say, oh, yeah, the Chinese totally had that before. We just didn't know it until recent years. Okay, so they're not necessarily part of our history is the way that goes. Okay, little story, theory maybe, about zero, and you can judge for yourself. There is absolutely, as far as I know, there is no foundation to this theory at all, except just a naturally occurring thing. So the idea is that, and I heard this, it's an interesting theory, if I was using rocks or pebbles to keep track of my sheep as they come and go, as I said earlier, to keep track of them, and I've got this pile of rocks, and as they come back, I pick them up and I remove these rocks. All of my sheep come back for the day. They're all back in. I'm happy. I didn't lose any sheep today. The idea is, what's left behind once I pick up those rocks? There's nothing left behind, right? All my sheep are in. But look at the sand. Look at the dirt where that rock was. There's going to be like a hollowed out, empty spot where I picked up that pebble and I moved it. So there's something in the sand. And what's it look like? It's kind of a circle, right? Okay, if they're smooth rocks, blah, 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 blah. So the theory is that maybe one of the places that a zero came from was from that idea right there. Pick up the rock, what's left over. Okay, that's it. All right, I don't know if it's true or not. There's no backing up for that at all. It's just an interesting theory that I read somewhere, heard about. So kind of cool. We're not going to look too much more at these early people, the nomads and the people just starting to settle. What we're going to do is on Wednesday we'll start talking about Babylonians and Egyptians, and we'll do some math the way that they did math, and we'll move forward. Yay. So that's it. Yeah, if you have questions, let me know.